Okay, everybody should be in your math modules on page 27. We're starting a new section, although this section is actually just going right on with what we had. In April, you should have your math book in class. That's part required. Go quickly. No. Hitler. I would wait just a moment. Okay, guys, here are our goals for today. We are going to still use greatest common factor and least common multiples, but today we're actually going to be using them to solve problems. So you have to not only be able to do the math, but you need to apply it to word problems. We're going to determine the GCF of two whole numbers less than or equal to 100, and the least common multiple of two whole numbers less than or equal to 12. So we're going to be doing the same stuff. GCF and LCM, as we just had on our homework last night. The big one is we're now going to be turning it into word problems and actually getting answers. So our review for today, we're actually going to get you guys to do the prime factorization of each number. Remember your homework last night? It has to be very specific. You can either do your factor trees or you can do the cake, your choice. But we have 4 numbers for you to find the prime factorization of. You got 3 minutes, go. Okay guys, I am going to use the cake method for prime factorization because I find it easier, because it should be really quickly. 21, can I divide that by 2? No, by 3. Yep. 3, 7 is one of my prime numbers, so I now just rewrite that as a multiplication sentence. 3 times 7. That's how easy prime factorization is, guys. 30, can I divide it by 2? Yes, I do it. 15. 15, can I divide by 2? By 3. 3 and 5, I'm done. 2 times 3 times 5. Should literally be this easy, guys. 42, can I divide by 2? Yes. 21, can I divide by 2? No, by 3. Yes. 3 and 7. 2 times 3 times 7. I actually really like this one. 19, can I divide by 2? By 3? By 5? By 7? If I've said no 4 times, what does that mean? 1. It's prime. So 1 times 19 is my prime factorization. Guys, if you will focus on your 2, 3, 5, 7, this should be a no-brainer. You do need to know your 7s down cold. If you don't know your 7 factors yet, make that your primary target over the next couple weeks. 3s are easy. Just add the digits. If it's divisible by 3, the whole number is. Then you got to do the math to figure out what it is. But determining if you can divide it is easy. Any questions on the prime factorizations? Okay. Let's turn the page. Go to page 28. Ow. Sammy. Hitting me in front of everybody. Okay, you can solve real-world problems that involve common factors or common multiples by thinking about the question you are trying to answer. So this is going to get to, we're going to actually formalize for you guys what you've already been seeing us do up here on the board. And it's called marking the text. Okay? So we have this nice little area up here at the top of our page. I want you guys to go ahead and right now, go ahead and mark this down. Right, marking the text. Write it, because you will be doing this all year. This is a requirement in math class. This is not optional. Actually, I think with Miss Einhorn, I might even be able to get her to agree to take off points on tests and quizzes for not doing it.
Oh, absolutely.
Miss McShan was a little less stringent about it. But
I am a strict teacher, and I am a math teacher, by the way.
Yes. There are 3 steps to marking the text. It's actually quite easy. Step number 1, I'm going to circle numbers and units. And that's whether they're written out or if it is just written in numerical form. Whether they write the number 3 or 3, either case I would circle those. Okay? Units is normally your customary stuff, feet, inches. But in a lot of problems, like you noticed in the problem we did in the warm-up, I underlined cats and birds, right? Because those were the units. That's what we were talking about. Step 2, Get back up there. Underline math terms. Here again is where your vocabulary comes in. Let me treat you right. Underline. So your math vocabulary becomes very important on this. But that's going to tell you mathematically the things that we are doing in the problem. Your third step is probably the most critical. So critical, we actually spent half of our second day together doing it. Follow directions, right? Box the question or directions. In other words, box what it is you're supposed to do. So that once you get your answer, you can go back to what is boxed and say, did I do what I was supposed to? Did I answer the question? Because if I do all the math, but I don't actually answer the question, did you do what you're supposed to? No. Do you get credit? No. Everybody good so far? Now here's some good news for you. You can do this as you're reading it. Okay? If you get into Avid or some of these other classes, they want you to read everything first. I'm not going to make you do that. Do it while you're reading it. It'll make it quick, but it's going to pull out all this information that you need. So let's practice together on number 1. And actually, we're going to change up our directions a little bit. This one says, consider each scenario, determine whether you would use either a common factor or a common multiple to solve it. We're actually just going to solve it, because solving it is not difficult, especially given the tools that we've already given you guys. Let's go ahead and mark our text though. Okay, number 1, hot dogs come in packs of 8, and hot dog buns come in packs of 6. What is the least number of hot dogs packs you can buy when you want to have the same number of hot dogs and buns? So there's our question. What is the least number of hot dog packs? Okay, hold on. We'll get to that in a second. But yes, they nailed it. Now, by marking the text, this is pulling the information out that we need. So we're going to just make this easy on you, because all I need to do is pick out my 2 numbers, right? 6 and 8. We'll find the GCF and LCM, and then we'll figure out what to do with it. Can I divide both those by 2? Yes. Yes. 3 and 4. Can I divide both those by 2? By 3. So I'm done. So what's my GCF?
2.
GCF is 2. My LCM is 2 times 3 is 2 times 3 is 24? But you didn't answer the question. What's 2 times 3? 6 times 4? Good. You were a step ahead because it's easy math, right? Now here's where the thinking comes in. I already know the 2 numbers I'm looking at, right? I either want the 2 or the 24. So go back to our question. What is the least number of hot dog packs I can buy to get the same number of buns and hot dogs? So which one do I want, the 2 or the 24? 24, because that's where they meet, right? So then I have to go back now. Specifically, I'm talking about hot dog packs. And we find out hot dog packs come in 8. So how many 8s do I need to get to 24? 3. Technically, they kind of gave me my answer right here, but go ahead and think through the process. So what is the actual answer to our question? Good? Go ahead.
It's the least number of hot dog packs you can buy when you have the same number of hot dogs and buns.
No.
Remember, there's 8 in each pack. How many packs?
3. You understand where you went wrong? Jacob's brother, I apologize. I still haven't got your name down. Where did you go wrong?
What?
Where did you go wrong?
I looked at the LCM.
Good. And you didn't apply it to the information. Okay? So that's, again, part of the thing was. Now, I wouldn't have jumped in and said you were wrong right away. I would have come back and said, so you're saying I have to buy 24 packs of hot dogs? And what would your thought have been? So you said 24. If I asked you, so you had to buy 24 packs of hot dogs to get the same number. Does that make sense to you? That you need 24 packs of hot dogs? No. So get back to, again, make sure you've answered the questions. That makes sense to everybody. Does everybody understand what we're doing? Good, because you get to work with your table to solve the next three. Okay? Mark your text, find the GCF and LCM, figure out which one it is you need, and answer the question. So we're going to give you guys about 15 minutes to knock this out. So I'm going to go quick on this because we're running out of time, but at least show you what should have happened. Zeb has 36 pencils, 45 erasers. He wants to use all the pencils and erasers to make identical packages for his friends. What is the greatest number of packages he can make? So 36, 45. Can I divide both those by 2? No. By 3? Yes. Gives me 12 and 15. Can I divide those by 2? No. By 3? Yes. Gives me 4 and 5. Can I divide those by 2? By 3? By 5? I know I'm done. So my GCF is 9. My LCM, 9 times 20 gives me 180. So which one of those numbers am I going to use to show the greatest number of packages I can make? GCF. So Zev can make 9 packages. We could go a step further and say how much would be in each, right? So he would have 4 pencils and 5 erasers in each package if you wanted to go the next step. The beauty on the cake method, guys, it literally will give all these answers to you if you know how to interpret the numbers. Okay, there are 40 6th graders and 24 7th graders in the after-school program. The director wants to create groups where each group has the same number of 6th graders and each group has the same number of 7th graders. What is the greatest number of groups she can make? So again, our number is 40 and 24. Can I divide by 2? Yes, so we do it. Gives me 20 and 12. Can I divide that by 2? Yes, so I do it. Gives me 10 and 6. Can I divide that by 2? Yes. Gives me 5 and 3. That's 2 of my key numbers, so I know I'm done. So my GCF, I just multiply them. 2 times 2 is? 4. 4 times 2 is? 8. So my GCF is 8. For LCM, I'm going to do it a little differently. 2 times 2 is 4 times 3? 12. 2 times 5? 10. That's why I did it differently. 10 times 12 gives me 120. Which one of those numbers do I need for the number of groups? Good. GCF. So she can make 8 groups. Again, we could take that to the next level and say how many are in each group. There would be 5 6th graders and 3 7th graders in each group. Are you guys starting to see where all these numbers come in? Okay? It's one thing to do the math. It's another thing to interpret it so you understand what's happening. Okay, every time Soraya babysits, she saves $12 of her earnings. Every time Aaron babysits, he saves $9 of his earnings. After babysitting a number of times, Soraya and Aaron have saved the exact same amount of earnings. What is the least possible amount of savings they could each have? Okay? So what is the least possible amount of savings? So we're going to start the same way. 9 and 12. Can I divide by 2? By 3? Yes, so I do it. 3 gives me a 3 and a 4. One of my key numbers doesn't go into 4, so I know I'm done. My GCF is 3. My LCM is 3 times 3 is 9. 9 times 4, 36. Excuse me. So what's the least possible amount they could both have? 36. Okay, so quick question. So what do the 3 and the 4 in this case mean? Yes? What?
Days.
What do you mean days?
Like how many days they babysat.
Good. How many days each of them babysat? So Soraya charges more, so it takes her 3 days. Aaron charges less, takes him 4 days to earn the same amount of money. Make sense? Okay. Here's why we did this, guys. This page is exactly what we just did.
No.
Yes, but now I was just saying find the GCF and LCM. Here's your homework. Let's go to page, and that's 31, not 30.
31 is that homework?
31, 32. It's on your agendas.
31 and 32. 31 and 30. This more going to be a big thing.
I'm giving you big hints on this one, guys. Okay, our first part, write a definition in your own words. So basically, tell me in your own words. What's LCM mean? What does GCF mean? Number 1, all of these, we're going to read and solve each problem. So we're going to mark our text. If you don't mark your text, on my side, I'm taking points off.
Yeah. Same.
Same on the other side. So both of you, Miss Einhorn's going to do the same. Thank you. So mark your text. The first one, you're going to be finding the LCM.
Right, LCM,
Right next to it, LCM. Okay? Our second, this one can be in seconds. I would put the answer in seconds. You can convert it to minutes if you want to. But, actually, I apologize. I hope the other 2 guys read this because it does say in minutes. So it gives it to you in seconds. You have to convert minutes because it tells you to. Number 2, it's going to be GCF is what we're finding. How many different ways can he divide the group? What is the greatest number of teams he can make so they have the same number 9 and same number 10? And do you think should he make it? So you got to think about what they're doing. Okay? That makes a difference. So that one, there's several different answers. You have to apply it. Go to the last page. Number 3, again, we're looking for the LCM.
we write this down or we messing around?
And this one, it's got 3 different experiments. So what we went over for your homework today, remember that? Those that did the stretch, that's a good example for you to find the LCM. Number 4, we're finding the GCF. And then this part B is going to be off of your top line on your cake. So you do the cake, it'll tell you on the top line. You just got to make sure you put them together. Number 5, again, you're finding the LCM. Part B, you'll find on the top line. Apply it directly. And your stretch is optional. Good luck, guys.